Okay, Dr. Kamaro here. I just wanted to go over briefly about how to comprehend this model. The model is a representation of bone histology, and I did go over this with the histology PowerPoint that you should have all saw a couple weeks ago, but I want to redo it again. So I'm going to do my art therapy up here, and then I'm going to show you how it correlates with this model over here. Okay? All right. So some of this is really all review for you guys, but I just want you to see it in one video. Okay. So again, what we have here is that if we're dealing with a bone, we all know that there is no bone that really is shaped like this except a doggy bone. Okay. But if we take a cross section and we blow it up, you will get this setup. And in the center, it's going to be hollow. Okay. In the center here, the hollow area, it's called the medullary cavity. And inside, you will have bone marrow. Whether it's yellow bone marrow or if it's red bone marrow, depending on the age of the person, that's what that is. And I don't want to go into details about that. Sorry. You'll get that in the lecture. But this is bone marrow, and it's located in the medullary cavity of a long bone. Okay? We will also see that the lining of the bone cavity, this area here that I'm doing in green, is connective tissue, and this is going to be referred to as the endosteum. Okay? There's also going to be connective tissue all around the bone itself, kind of holding the whole bone together. This is referred to as the periosteum. Okay? If you ever go to KFC and you finish your chicken bone, get the chicken bone and take a knife and kind of scrape at the outside of the bone itself. You're going to see it start fraying up. That fraying is actually the periosteum, and you could enjoy that in, with your spouse or whichever, and say, "Look at all the periosteum." And you go, "Oh, gross." Okay. All right, but that's the periosteum. We will also see in around the endosteum a woven type of bone, trabeculae, and this is referred to as spongy bone. Okay? Again, the functions of all this you'll learn in lecture. I don't want to delve into that for this particular video, but that is spongy bone. Okay? Sorry, can you get that? Spongy bone. Okay? Then what we have in this area here, which is the majority of the bone itself, which gives the hardness, the concrete, quote unquote, concrete of the bone, you will have it having all these circles that look like tree stumps. But from a distance, they will look more or less like target cells or bullseyes. Okay? Now I'm not going to do the whole whitish area. Just assume that all of this is going to be all throughout the white here. Okay, I just don't have the time to go through it all. But understand that that's what's happening here. And you will have it kind of looking like bullseyes, targets, what's happening over here. This is what we refer to as compact bone. Okay? Now, it's important you understand about each one of these functional units, these so-called bullseyes or tree stumps. Each individual one is a functional unit of the bone. So why don't we take one of those target cells, or they're not cells, I'm sorry for using that word, but one of those bullseyes, and we blow that up. Because we got to look at that closely too. and we have this. And it'll look like a bullseye. In the center, there's going to be a canal. In the center, this is where you're going to see, well, okay, this canal has a few different names to it, okay? This bullseye, the target, okay? It could be called the osteonic canal. It could be called the Haversian canal. It could be called simply the central canal. You'll find out in anatomy and physiology, for you to master an A&P, you got to know how to say one structure about 12 different ways. It's a crazy thing, but you'll see there's a lot of different ways of saying it. For you, you got to recognize all three, but if you have to write down something like fill in the blank or something like that, do the one you know how to spell, okay, because spelling counts, all right? But do recognize that it has a few different names to it. Now, also, I want to make point that this functional unit, this whole thing here, has a certain name too. This has, it could be called two different things. We could call it a Haversian system, or simply an osteon. Okay? So the compact bone is made up of many osteons, or Haversian systems. Okay? The center part over here, like I said, it could be called the Haversian canal, which is based on that. It could be called the osteonic canal, which is based off of that. Or it could be simply called the central canal. Okay? Inside the central canal, there is going to be blood vessels. These blood vessels are referred to as the Haversian blood vessels. And these are the main blood vessels that are going to give blood supply to the compact bone. You will also see layers going on here. These layers are referred to as lamellae. Okay, I don't have much room to put everything else on here in words, but just refer back to the histology section. You'll see it all in there, all the words and stuff. So these concentric rings are referred to as lamellae. Okay? On the lamellae, you will also have these so-called watermelon seeds, or at least they'll look like watermelon seeds. These are really little pouches, pockets, that something could actually, quote-unquote, live in. These pouches are referred to as lacunae, okay? One lacuna, many lacunae, okay? Inside there, you will have, let's make it a little bigger so you can see what's going on here. You will have a cell living in there. This cell is an osteocyte, which I'm kind of doing in green here. An osteocyte is a living thing. All of this is made up of mainly phosphate crystals and calcium crystals. Okay? That's referred to together hydroxyapatite, but again, referred to the lecture. That's what gives the hardness to the bone. Now here's a problem. We have a lot of blood vessels that would be in the Haversian canals, central canals, but we need to get the nutrients that are in these blood vessels to the farther areas. But there are no blood vessels out there. So how are things like calcium and glucose and oxygen going to go from here into the osteocytes, which is a living cell that needs those things? Well, we have little trenches that are coming out of these lacunae. These trenches are little canals that are referred to simply as canaliculi. And I know that sounds like a big word, but look at the first 5 letters is canal, which is that. Licui is small. So these are canaliculi, meaning very thin or small canals. And this is what happens. They're all over here. They kind of are making it look like these are little spider legs, right? And what's happening here is that the nutrients from the Haversian blood vessels, in order for it to get over here, it will pass through these canaliculi, through these little trenches, so that the cell in the lacuna, the osteocytes, absorb those nutrients, oxygen, glucose, calcium, and so forth, so that it actually will do what it needs to do. And when it's done with that, or there's too much there, they will pass the nutrients onto the next osteocyte in a nearby lacuna by way of this canaliculi, and so forth, and so forth. And it goes out and out and out. So these canaliculi are very important to be able to transport the nutrients from osteocyte to osteocyte. Okay? And that's what's going on over here. So what is this model all about over here? Okay, what this is this picture right here. Okay? It's a pie shape of this. So we're kind of, and I'm going to draw that on here, but you're basically making this kind of setup. See that? And that's what this is here. It's as simple as that. Okay? So, if I asked you this bluish area over here, what is that? Right, the periosteum. If I said this area in here is filled with what? Bone marrow. Okay? This area here, okay, I know it's hard for me to direct it, but this area here is the spongy bone. And then most of this, which I'm going to show you in a moment, is going to be all compact bone. And you'll be able to see each osteon, you'll see other things on there, which is what all this is. Okay? So let me show you this using my document camera. Okay?